Okay, we'll get started, okay? So last time we talked about tokenization. That's in lecture 2, we talk about tokenization. So basically you have some input, right? You read it in, and then you would like to determine what is a token. So token is the starting of a parenthesis, ending of the parenthesis, or some A, B, C, the numbers or words. Okay. So those are determined of the tokens. And to determine this starting of the token and ending of the tokens, we call it lexical analysis. And lexical analysis, you need to analyze the structure of each word or each tokens. And then last time we introduced the idea of regular expression. The idea of regular expression. And regular expression provide a grammar to analyze each word, such as the structure of a phone number, the structure of a integer, or the structure of an email address. Those kind of the grammar, we call it regular expression. And the purpose of the regular expression is to help the tokenization, okay? So after tokenization, you will get a lot of the words. So you have if A equals 3, something like that. You tokenize it into grammatical units. Each grammatical unit is a word. And then the token type, maybe you get the token type of this one is a keyword. This one is a parenthesis, left parenthesis. This one is an ID. This one is an operator. This one is a number. This one is a right parenthesis. Okay, so that actually show you the structure of the show you the different token types. So at the tokenization stage, you determine the token and the token types. Okay. And then today we are going to talk about, after you do the tokenization, then you would like to analyze your structure of your tokens. So in order to study the structure of your tokens, this one we call it parsing. Okay. This one we call it parsing. A parsing, usually in compiler, you have a complete parsing tree, but today we don't go into the detail of the parsing tree. Parsing is the interpretation of the grammar, okay? The interpretation of the grammar. So we basically try to parse the structure tree such as 1 plus 2 as a structure of a 1 and then plus 3, 2, 3, okay? And this plus is an operator. So that actually is a parsing tree, okay? And then this parsing tree we actually is more complicated, and that is a topic in compiler. So basic, that's already level 4. In level 3, we talk about the structure, data structure, and algorithm. So basically, that's beyond the scope of the course right now. So right now we are talking about using stack to help you to do parsing, and what kind of parsing can be done. That is actually the kind of algebraic expression. Algebra expression can be analyzed using your stacks, okay? So that's actually the relationship of the previous 2 lectures and today's lectures, okay? So today we are working on the algebraic expressions. So first you need to know about what is stack. Stack is first in, last out. Also called push down step, okay? But it actually is first in, last out. And you do have a push and pop operations, okay? But this push and pop operation can change the order of your data and also can provide the kind of the reorganization of the words. Okay, reordering of the words. So they are function of the push, pop, and pick. Okay, and then C++ do have a stack, and we already teach you what is a stack. Okay, in the chapter 12. Okay, and in the STL, standard template library. Okay, we already teach you what is stack for push, pop, and pick operations. Okay, so for this part, we don't create a new stack. But here, let's actually look at it. Okay, let's look at this STL or stack. Okay, so here we do have a C++ stack, and they are empty, they are top, they are push pop. Okay, push pop, and top will return the reference of the topmost element in the stack. So this one is actually a pick function. Okay, it's the same as the pick function. Okay, and you do have a push and pop. Okay, and that's the same as the push and pop described over here. Okay, there's a stack, push and pop and pick function, and checking empty and size and check empty. Okay, these are the functions that we have using the C++ part. Okay, so we do have some example right here. So let's do this. Okay, I'm going to copy this one and just put it in on our example. Okay. So today I'm going to create a chapter topic file. Okay. Let's call it algebraic. Expression. Okay. Using the stack to interpret the algebra expression. Okay. So use this library. So first one, let's look at stack. So we have a program called use stack.cpp. So this one is show you how C++ stack being used. Okay, so we just basically use a stack of integer and then push, and then push a number of 0. Okay, so 21 go in first, and then 22, and then 24, and then 25, and then push a 0, and then pop 0 out, and then pop 25 out, and then pop 24 out. Okay. Okay, while it's empty, and then you do looking at the top and pop. So you top and pop, you push out, pop out 20 and 21. So only 21, 2 and 21 being pop out and print. Okay, so that's wrong. Okay, so only 22 and 21 are pop out and wrong. Okay, so that part is okay. We actually just want to show you how to use stack. Okay, that's good enough. Let's go back. Okay, so today we actually know about what is stack. That's good enough. Okay, and stack's operations. Now next one, we are going to implement stack using Python. Okay, this one is wrong. Okay, here actually This course is C++, and at that time, I'm just borrowing the Python course material, but I haven't changed it yet. Okay, so here, let's change it in C++. Okay. So this implementation stack, we don't need it. Okay, we actually kind of has heavy stack, so we don't need it. There's also using array, we don't need it. Okay. Now, simple balance parentheses, we talked about it last time already. Okay, this one we already talked about. So we go down to the algebraic expression. Okay, so algebraic expression. So the algebraic expression is to have some expression that combine the operator and the operands that represent a specific value. Say A equals B plus C. Okay, so A, B, C, and plus and equals, these are different tokens. So there are three operands. Operands are A, B, C. Two operators, plus sign and the assignment sign equals. Okay. These are operators. So an operator is that to tell the computer to perform a certain mathematical or logical manipulations. Okay. Operand is the value that you perform on. Okay. So this kind of the things, we call it algebraic expression. So when you do tokenization, you do have A plus, I'm sorry, A equals B plus C. And the token type is operator. So operand, let's call it ID. Okay, so operands, operators, operands, operators, and operand. So these, when you do tokenization, you do tokenize these one by one. And at the same time, you also token out their token type like this. Okay, so for the tokenization, the previous two lecture, we already talked about it. Okay, so that's actually what we want to do. Okay, after that, we need to deal with the different algebraic expression. There's a prefix expression, infix expression, and postfix expression. So prefix expression put the operator at the front. So operator and two operand. Infix put the operator in the middle. Okay. Postfix put the operator at the end. So usually, because a human being using the infix, so you are putting your infix, putting your expression in infix. But when you evaluate a value, postfix is more appropriate. So usually we have the task of converting from infix to postfix for evaluation. So this is what we want to learn. Okay, that's what we want to learn. So basically here show you what is the infix, prefix, and postfix. So infix is 2 plus 3 parentheses times 7 percentage 3 parentheses. So 2 plus 3, you got 2, I'm sorry, 2 plus 8, 2a plus 7 percentage 3, you got 7, 3 percentage. And then time after. So this is the so-called postfix. Okay, postfix. 2 operand and then a operand at the end. Okay, so you got this value. So your operator also may have the precedence levels. So each operator have its precedence level. So operator of higher preference levels are used before the operand of lower precedence level. So this means you may have time, you have a plus, minus, you have divide, and percentage. So these three a higher preference than these two. Okay, this will be done first before this. Okay, that's what he say. Okay, so basically the expression of this one, you actually do B plus C first, and then you do A plus B times C. Okay, and then you finish this. So this one show you when you properly do parentheses, the infix representation with a parenthesis would be something like this. This is, we call it fully parenthesized expression. Okay, it's called fully parenthesized expression. Now we will talk about how to convert infix to postfix. Okay, so infix to postfix, we will do this algorithm. So scan all the symbol one by one from the left to the right. Also give us some value. So if it is an operand, then press it to the postfix expression. So it's a postfix expression ready to use. So if you look at the operand, so you put the two directly. Okay, if it is a left parenthesis and you push to the step. Okay, if it's a operator, it is an operator, then actually repeatedly pop from operator to add the postfix expression. Okay, so when you see this one, the operator, then repeatedly pop the stack and add to the postfix expression each operand on the top, which is the same precedence or higher precedence than start. So only any one of the higher precedence or the same precedence level will be pop out if you see an operand. So here, like this one, level 2, then any of the level 3 or 4 will be pop out. Okay. So this happens when you have 2 plus 3 times 4. Okay. So basically you put 2 in there. Okay. And then you see a plus sign. Plus sign, the stack has nothing. So you just push it I'm sorry, to put it into a stack. Okay. And then you see a 3. Okay. So you do a 3, push to the 3, and then you see a star. So you deal with the 4 then, and then you pop out the operand to put them together. Okay. And then if you see the right parenthesis, repeat the pop from stack and then add the post. Okay, whatever this one tell you when you see a right side, what you should do. Okay. So we do have this, and then the step is we do have this, and the step will be initially is an empty step. So you see a left side parenthesis, you push it to the step, okay, and then you see a A, okay, no operation since A is operand, so you put it to the output postfix expression already, and then you see a plus sign, so you actually push it to the step, and then you see so it actually is A plus B times C plus D. Okay, so basically you, at this moment, you see a B, okay, so you actually see a B and then you put B into there, so you have the A, B right now in the postfix. And then you see a right side parenthesis. So right parenthesis, you pop out the operator. you pop out operator. Okay, that's when you do have the right side operator, you need to pop out something, so you pop out the operator. Okay, and then you actually see a star, so you push the star into the stack. Okay, so when you pop out the operator, you also pop out the left side parenthesis. Okay, and then because you have one right side parenthesis, you need to pop out the left side parenthesis as well. Okay, and then you see a left side parenthesis here, and then you see D, so you put C in there, and then you see a D, you see a plus sign, you push the plus sign into the stack, and then you see a D, okay, you put D in the output expression, and then you actually see a left side, a right side parenthesis. So at this moment, you pop out the minus sign and then pop everything out until your parenthesis. And then at the same time, it pop out everything from stack when it's not parenthesis. So you are going to pop out star as well. Okay, so this algorithm will convert your infix to the postfix. But the whole thing is that the grammar wise, you must provide a fully parenthesized expression. Okay, the idea is that before you can do this one, you must provide the fully parenthesized expression. Okay, let's check actually the internet to see if there is a word an algebraic expression into fully parenthesized expression in C++. Okay, let's see if there is any way that can do repress. Okay, AI have something. Okay, let's try this AI, see if it can work. Okay, I never used this before. Okay, but let's try this one. Okay. Okay, anyway, I never used this one before, but let's try. It's called fully parenthesized program. Okay. So you got a string, and then you enter an algebraic string. Okay, that from your input. Now we know, and then you run fully parenthesized. So that will convert your expression from the string expression and then get delivered to the result, and the result will be printed. So this part is okay. And then this conversion of the fully parenthesized string is that you get that, and you have stack of the operands. So you get that, and you take character. So for the expression the length plus plus, okay, I plus plus, if it's a space, you do nothing. Okay, if it's space, so basically you see some space, you do nothing. If it's a number, you push the number into the stack. If it's the left side parenthesis, you push the left side in parenthesis to the stack. If it's the right side parenthesis, then you need to pop out something. Okay, so you look at the operator. Okay, so you have an operand and operator, different two stacks. Okay, so you have 1 plus 2. Then this one push to the this one push to a stack, which is stack. Parenthesis is pushed to operators. Okay, so this operator stack. Okay, parenthesis to the operators, and one push to the operand. So let's call it ID stack. So you push this one to there. Okay. And then And then right side, you pop in. Okay, so pop in, let's actually look at it later. Pop in, let's look at it later. So if it's operator, then you need to pop out different operator out. Okay, and then it's empty, whatever. Okay. I don't know this one is trustworthy or not, but let's run it to see if this one works. Okay. So this one, because you have the input from the outside, so we need to use a terminal. Okay, you do perform fully parentheses. I think this one is a very common function, so this AI program may be working quite well. Okay, so let's do 1 + 2 × 3. So 2 and 3 should be parentheses first, and then 1 is later. Okay. Okay, so this one will give us a good fully parenthesized expression. Okay, so you don't need to, you can study this code. Okay, we don't need to waste our time to study how to convert the fully a string from non-fully parenthesized to parenthesized program. Okay, any questions so far?
No.
Okay, so nowadays you should learn how to example program from AI. Okay, it's very important. Will save you a lot of time. So that save us the first step of the creating something that is fully parenthesized. So we don't need that anymore. Okay, we actually know that we do have the code. Okay, so this one is a very standard program. So I think that AI can do very good job. Okay, they basically can copy from a lot of people that write that program before. So that's not a problem. So we got that, and then okay, so that we know already. So next one, actually, this one, the step, we already know what is step. Okay. The precedence level, you do have the related precedence level. So this one, I think in the program, we do need to use a map. Okay, in the program, we do need to use something called a map for it. Okay, using a map. Okay, so you create a map, a dictionary, and then you actually map 3, 3, 2, 2, 1. So parentheses is lower, and then plus sign. Okay, so let's create a map let's create a map in C++. Okay. So that's actually still example of program. Let's don't do coding by ourselves. So C++, map of character. I'm sorry. Let's call C++ map of char and integer. Let's try this one. Okay. Let's directly copy this one as well. Okay. This one is map of char and integer. I'm trying to basically this kind of program because it's quite standard. So I'm trying to it's a little bit too much. Okay. Okay. I'm sorry. This graphing is actually not really that easy to use. Okay, let's see. This one called string holder. Let's call it string holder. So this string holder is created string holder of the alpha n and beta n. And then I don't think this one is what I want to have. Okay, so this one, let me delete it. Actually, it's not what I want to have. Nothing that actually that we would like to have. Okay, sorry. I don't actually want to use this kind. It's not map of integer and char. Okay, let's just do whatever. I think still AI more reliable. Here you do have this. Let's actually put it here. Okay, let's copy. Okay, let me call it. Let's call it map chart. Okay. Let's call it map chart. Here, I just want to let you know that we actually do get some code from it. Okay. Okay, so basically, this one I see missing this. So AI sometimes miss here. Okay. This one do miss something. You have created the map of the chart, your character count. Okay, so you actually chart count, you put the value in there, and then you do create counting of the numbers. Okay, you kind of printing it, and then you check the count of the B. Okay, count of the B is the chart count function for the B character. I'm not sure what this one will check in for the key's existence. Okay. Or using count function to see if it's existence. Okay, whatever. And then this one goes through every single pair to get the first item and second item in the map. Okay, so this one I think it's okay. So that's actually wrong. This one do not need the input, so don't need the terminal. Okay, so it actually check how to use the character count. Okay, but anyway, that's not our purpose. Let's go to our this one called index to postfix. Okay, this is the program that we want to create. Okay, so in infix and postfix, we want to copy these two. Okay, and we copy these two, and we would like to. Okay, we would like to use map. I'm using okay namespace std. Okay, now we want to create type. Okay, define. Okay, this one is the map of char and integer. I think we don't need type define because we don't need use it too often. So let's just use this. Okay, create this one, and when that have the phrase okay, presence level, and then this one remember using map, you can use this second level array to directly create it. Okay. So you should have the character this is level 3. Level 3. Level 2. Level 2. Oh, I'm sorry. Actually, this one level 1. Okay, so level 1, let's have the right side bracket. Let me check it. Okay, one more time. This is 3, 3, 2, 2, 1. Okay, that's actually the value we do it. Okay, so this one is minus sign. This one plus sign. This one division. This one. Fine. Okay, so you set up the presentation level that you want to have, just like that. Okay, and then you do the main program. Okay, boy. Okay. Zero. Okay. I use the AI because I think that I want to make sure that you know that nowadays doing programming is faster. Okay, but when you need to learn something, don't use AI. Okay, please don't use AI. So right here we actually go through the different precedence level to get every pair. Okay. And then you actually see out the first one and then see out the second one. So I just want to validate your map is working. Okay, that's the whole thing. Just want to validate they are working. Okay, so every time you get a pair from the map for the first item and second item, and that map is precedence level. Precedence level. Okay, so we create a map like that. Okay, so that show you all the precedent level you have. So that's actually what we want to have. Okay, so far this one is what we want to have. To using the map and then create a precedence level. That's what we want to have. So this one for testing, but later we kind of don't need it. So let me comment it out. Okay. This part is for the sortation of map. Okay. Okay, that part is okay. And we are going to start from here. Okay. So that part finished. Next one, you do have convert expression. You put a expression there and then you convert expression. And this is Python code. Okay, so I'm the Python code. So we are going to convert a Python code of the conversion of the of the C double plus sign to infix to postfix. Okay, so we do get I'm sorry. We are here present level. The step, the precedence, and then here, okay, we are up to here, okay? So this one is a convert function from infix to postfix. So this there is a convert expression function, and you use a convert of the expression the split. Okay, so there's a function called expression split. You kind of put that expression the split into the expression function. So we will study the expression of this split for later. Okay, but right now, basically, after the split, you got the tokens. So basically, you are feeding the token to the top underlying number. Underline means the private functions. Okay, means private function. Private functions. Okay, you have a private function to convert the tokens. So this one is we get the tokens. It's a sequence of the tokens, array list of the tokens. Okay, so you basically get the array list of tokens. So you have a postfix list. Postfix by itself is a list as well. Okay, and then you are operand the stack. So you need to have a stack. You need to have a vector for the postfix and the stack. Okay, and then every time you got a token from the tokens, if it's an identifier, you put it into the postfix. Either parentheses, you post it in the stack, operand stack. If it's the left parentheses, you perform the file true and then you pop it out, whatever. Okay, and then else other it must be either not right parenthesis, not left parenthesis, not available. Then it will be the a operand. Okay, it will be an operator. So it's a plus sign, minus sign, or time, or device over here. Okay, this is left parenthesis, right parenthesis. This one is number or variable or ID. Okay, so these are three different operations. Okay, and you finish everything, and at the very end, you actually pop out everything one more time. Okay, so basically, this is the algorithm. Okay, but we do have some more things that we need to do. First one is we need to split the string into the tokens. So this one is tokenization need to be done right here. Okay, so tokenization we studied it last time already. So we will convert the tokenization later. Okay, and then there is a checking of the character is that if it is a identifier or not. Okay, for the token. Checking if a token is by itself a identifier an ID or not. So basically, you check if it is a parenthesis or not. This is not token. This is not token. And then numbers are tokens, and then variables are tokens, are identifier. Okay, by doing that, you should be able to do that. Okay. Okay, so we will work on these two functions first. Okay, split function and ID function. Okay. So let's look at the ID function first. Okay, so ID identifier function is that you do the right rule for ID. Okay, so ID actually this one is using the regular expression to finish it. Okay, regular expression you do know how to do ID. It basically you can look at the regular expression. So there's two string function. So that actually will convert. Okay. Okay, let's see. Present level. Okay, so here one way to do is you use these. Okay, token in this or token in this to see if it's an ID. Okay, we will write a different way. Okay, we will write a different way. We don't want to use this one. So let's look at how actually let's actually have two way to let's look at this part is ID function. Okay, so its ID function has the two. One is number function. Okay, and then one is variable name function. Okay, and then let's call this two as is ID function. So let's actually look at here. Let's call it C double plus check this number. Okay. Okay, so here is digit. I don't want to have each digit. I want to check if, let's actually put one more thing there. So C double plus regular expression to check if it's okay. So here it actually we select it's integer. Okay, here is a check if it's integer. Let's see, I don't want to check integer. I want to check if valid integer or decimal. Okay, so this one, let's try this one. Okay. So this one is called is number.cdd. Okay, you see nowadays there are a lot of functions that you can use. So this function is to check if a string is a number or not. Okay, so right here, because your backslash in string will be treated as a escape sequence. So you need to put it as full slash, okay, for one. So this one, let's use it, okay. Let's use it. It's very short, so it's already can be used. So that's include IO string include ranges, regular expression, okay, and using namespace std, okay. Oh, we also need to use a string, so let's do include, okay, string. So everything just okay. Okay, so this one is actually really shorter. Get a string and check if it is regular expression is actually. So this one put enough to check if a token is a number or not. Okay. Okay. So let's do integer man. Okay. Boy. Zero. So here let's create something called vector of strings. Okay, this one called tokens. And let's have 32, 42.1. Okay, whatever. And then A, B, C. Okay, let's have this three, and then oh, we don't have vector. So that's actually we also need to include vector. Okay. Let's also include vector. Okay. Then let's do for which is true as from tokens. Out, okay, that's tree. And you have region match. Okay, so here you need to create, you do need to have a boolean, you need to have a string. B equals rematch result. Okay, of your string. Okay. And then you will be returning true or false. Okay. So it to check the true or false. Okay, is it so far okay? Is it so far okay?
Yeah.
So let's do this. Okay, so let's do this. Let's actually do here, changing this match a little bit. So here let's have a string e. Okay, let's do string. Actually, let's do have a regex e. Okay, and then put this one outside. Okay, this one call it numbers. Okay, so put this one right here, numbers. So this E, okay, and then we are going to do this. So this one is a rematch of the S versus number. Check, we mention S. Okay. So by the way, let me ask you a question. For Helen, it is okay to do user code using the OpenAI to help you to do programming or not?
Like, it's not allowed.
Is it allowed or not allowed?
No.
Are you sure?
Yeah, I don't even think they allow you to use like pre-written templates anymore.
Oh, okay. So be careful, okay? But in real world programming, I think it's okay. I'll check the rule for OpenAI in for user code. So how much we can use? Probably just getting the remix some function that is maybe okay, or even this is not okay. I don't know.
I think you're not allowed to go online at all because I think they said they are trying to make it like a platinum like passing thing. It's weird. I think they just changed the rules.
They changed the rule already. Okay, okay, I see. That is good or bad, okay? Good or bad. But anyway, right here, because we have a lot of things we need to learn. So basically, I try to utilize as much resource as possible. Is that okay so far?
Yeah.
Okay, because we do want to teach you the real world programming. We don't want to teach you. So we do teach you what's a regular expression, right? Of course, you can figure out a regular expression, but it takes you a lot of time, right? It take you a lot of time to figure out what is numbers. Okay. So here, let's try one more thing. Regular expression, variable ID. Okay, that's what I want to do. Okay. There are variable expression for regular expression for ID and variable. I forget one thing. I forget to put 3,000 plus. Okay, let's try this. Trust this one. Okay, I think this one is okay. Okay, this one is okay. So let's actually copy this one. Okay. So let's call it IDS. Okay, so basically this one you already can check if it's a number or it is a ID. That's what we want to do, right? And later when we do the if to postfix, you kind of tokenization, you would check against your numbers and ID for each tokens, okay? For each tokens. So that's the purpose. We teach you regular expression and tokenization first, okay? Now let's actually copy this one. Okay, let me do this. Okay, so here it will be is number is B. Okay, so let me actually copy this one. So this one will check against the same thing. We'll check against ID. And let's copy and paste. And this one is IDs. Okay, is this good enough? Okay, good enough. So let's say, and then let's put one more endo. So 32 is number is true. 32 is ID is 4. 42.2 is number is true. 42.2 is ID is 4. This one actually okay. So we do have a good checker for ID and numbers. Okay, good enough. That's what we want. Okay, so that one we solved. That one we solved. Go back. So this one called this one we solved. Okay. So let's actually do one more thing. Let's do C double plus tokenizers for algebraic expression. Let's see. Okay, let's trust AI one more time. Okay. So there's a tokenization. Basically, you get a string and then do whatever they want to do. Okay. And then it got this, we do tokenization. And it got into vector of the tokens and then that print everything. Okay, that's a trusted. Okay, one more time, that's trusted. So you see, I teach you the concept of tokenization and then regular expression. And today I'm going to teach you how to use that in the regular programming. Okay, that's the purpose of solving problem with data structure and the algorithm. Okay, and right here we are using step and all kind of STL to solve the problem. Okay, to solve the problem. So here this one, let's call actually call token neither. That's CPP. Okay, let's call it token neither. Okay, so we do got a tokenizer, but I'm going to change it a little bit. Okay, so here I'm going to do using name space STD. Okay. So I'm going to delete this one. Okay, so let's do request. Okay, when we see STD double colon request with empty sign. So let's do it this way. So let's do it this way. Let's do Let's do request. Okay, done. So now this is a tokenizer. You got a string pointed into there. You create a vector of the string. That's a string. So every time you got from that string, you got a token and then space. Anything with a space, okay? And then your token is empty and the size, whatever. And then you do checking this digit. Okay, let's see if this one work. Okay, you got this one. Let's see if it work. Okay, so you token out these different things. Look like I think it's okay so far, right? Right? So far, so good, right? Okay, so that's actually okay. Then now what we do is like, let's go back to postfix to prefix program, okay? Stage one, we will do in the string, okay? Step two, we would actually convert the string into fully parenthesized size. Step three, we would do token validation. Step four, we do checking if they are numbers and variables. Is that okay so far? So far, okay, right? So let's do it, okay? So first one, we would create a string. So this one is actually in the tokenizer. So we would do expression, okay? So this one is to index. So there is a string expression. Okay, and then you see out. Okay, see. Okay, so this part. Okay, second one converted to fully parenthesized. Then fully parenthesized is in full. Or you have another thing you need to do. Anyway, that's actually copy whatever function that you need to include first. Okay. And then let's put those functions under map. So this is operator different one. Let's copy this whole thing. Okay. Copy over to here. Right. So this one is fully parenthesized. Okay. So this one can check parentheses. So let's use this one. We do see in whatever, so we need to have this one see in expression. Let's use this one, okay? Let's use this one. Put it over here. Okay, so this part, let's actually use the same function, okay? We use over there. This two, let's actually do cut. Put it over here. Okay. So we do finish the first two steps. We will do tokenization later, but at this moment, let's do save. And then let's run it. Oh no, we need to use terminal. We cannot use this one because there is input. So we do save and then we do terminal. So G double plus infix to postfix plus CDP HO infix to postfix. Something wrong, precedence. Oh, I'm sorry. Fully processed already has a precedence. I'm sorry. So they actually have conflict between the name because fully processed have already has a precedence level function. Okay, they do have a precedence level function. What should we do? Is it in 0 to 1? Let's say character level. We are using math. We should put them together as a one data structure. Okay, so we do use a let's do this, okay? Since this has the conflict, we should use the one that we want to use because later we are going to use this one. So it's a 3, 2, 1. I'm not sure whether they will work or not, but let's do this. Okay, let's actually comment now this one. Okay, so let's assume that we do have we do have a precedence level. So there is a precedence level. Let's actually look at the precedence level. So this one precedence level, let's actually change it into bracket because it's a map. So let's change it into bracket. Instead of function call, let's use a bracket. Okay. And then what else? Okay. So there's let's see. I'm not sure there are some other conflict or no. Okay. Let's say, okay, let's do it one more time. Okay, so let's run infix to postfix Let's do 1 plus 2 times 3. And let's do, we want to have a fully parenthesized, right? So let's actually do this, okay? Do this. Okay, so we do create a fully parenthesized string, okay? So that part is done. So basically, originally, this one is using a function, but now I convert it to using the map I already has, okay? I kind of changed it to there. So this no longer needed, that's deleted. Okay, that's deleted, no longer needed. So this part, okay, you had a present level, you have parenthesize, the part integrated. Next one, we will do tokenization. So let's go to the tokenizer. And the tokenizer, we do need to have this one. I think this one and vector are needed. Let's copy these two. Okay, vector and the SS3. Going back to tokenizer. So in tokenizer, you do have the tokenize function. Let's do it. We do have tokenizer. Let's copy the function, put it into the index and postfix. Put it under the fully parenthesized. Okay, put it under the fully parenthesized. So we do have a tokenizer. So next one, we are going to copy the example into here. So the example is tokenizer. You do have the fully parenthesized. Now you are going to fully parenthesize to token and then vector out the token. So let's copy this part. Okay. Put it back to here. So right here, let's put it over here. Okay, so right now, it's not expression got tokenized. You need to do the result to the. So here, let's change the name to result. Result is fully tokenized, and you break down into tokens. Okay, so here you would say tokens. Okay, so this one. Okay, let's say. Let's do the previous operator. So I use an arrow and you would do the previous operator and let's go. Oh, no, I'm sorry. I have a. Okay, let's do G++, index to postfix, that's C, PB, HO, index to postfix. Okay, and then index to postfix. Okay, you want to enter something, so let's do 1 plus 2 times 3 minus 2. Okay, let's go this way. So we fully parenthesized, and the token actually did not token things out. Something wrong. Okay, it actually is together, everything together. So tokenizer should create a this one. Why it doesn't token out? Let's see. Let's go back to our tokenizer. It need to be separated by space. So when we do token, actually the space is used to do separator. So this tokenizer is no good. Okay, so basically this tokenizer is not good. This tokenizer doesn't separate the tokens. It is using space to do split. Okay, it's using space to do split. So if there, let me check this tokenizer one more time. Okay, going back to this tokenizer part. Okay, let's run one more time. So it is well tokenized, but if we don't have space, let's see, if we don't have space, what happens? If we don't have space, it doesn't tokenize. That's actually wrong. Okay, sorry. That's not what we want. Okay, this one is not good enough. Okay, so let's try different things. Okay. Let's try another one. I think last time we are trusting AI. Let's do different one. Okay. Let's do this CW plus algebra calculator. No, this one is not open either. Okay, so far that these different tokens all need to be separated by space. So that's actually for the time being, okay? Because we don't want to go into the troubles. So that's just using the space as a separator right now. So let's don't improve it at this moment, okay? So let's just do it in this way. So let's see. Let me keep the tokenizer in this way. Okay, whatever. Let's go back to full this one. Go back to the terminal. Okay, let's do index to postfix. That's 1 space 2 times 3. So we need to fully parenthesize it will actually it already group them together. That's a problem. Okay, that's a problem. So let's actually do this among the tokens. Let's go back to look at the token. I mean, conversion of the fully full. So the full operand, we actually full operand we do fully print. So we got a string, right? And then we in is number and then pop out whatever that's actually do. So at the end, we actually would return operands. Operand is the step of string. So you actually, let's see, fully parenthesize. So you fully parenthesize, you've got a string. And then your return value is the last element in there. Okay, it's the last element in there. So these two, let's try this. Okay, let's try this. When you push in, let's push extra space in here, extra space in here. In between the operand, let's do this. Let's do 2 extra space there. Okay. Let's see if this one works. Okay. Okay, let's do this. Save. And this one is inside the so-called this. Okay. So this one is in the so-called full function. Okay, so let's do this. So this one called full. I'm sorry, G double plus for the CBB dash O full. Let's go full 1 plus 2 times 3. Okay, this work. Okay, this one it work. Let's go back to this infix problem. Let's do the same thing right here. Okay, so actually, the only thing you need to do is to go to the when we create operand, you add extra space on purpose to separate them. That's good enough. Okay, you don't need to change the tokenizer for more complicated situation. Okay, that would be a fix for this problem. So we standardize the fully parenthesized string using the extra spaces. And that is good enough. I think that's good enough. Okay, so this one, okay. Then we do have the fully parenthesized token. Let's actually save and run it one more time. So it's T double plus infix to postfix. CBD dash O infix to postfix. So infix to postfix. Then 1 plus 2 times 3. Okay, so you got the tokens this time. Any questions so far? Okay, so far we can enter a expression. Then we actually, based on that expression, we do fully parenthesized After fully parenthesized, we create a token string. Okay, we create a token string. So that part is also done. The next one, we are going to convert a token string into the postfix. Okay. So that tokenization is okay. And then you would like to basically next one is that you need to have a postfix. You had a token list already, right? You had a token list that you can check if it's a number or variable, that's fine. And then you need to have postfix list, okay? And then if the token is parenthesis, token parenthesis to list. Okay, so that's actually next one. Trying to convert this Python code into C++, then that should be fine. Okay, this one should be fine. So let's do this. Let's actually copy this define function. Okay, into our C++. Okay, and then go back to here, continue. Oh, that's it. That actually is very short, not too much. Okay, let's do it. Okay, let's do it in this way. So go back to our here. Wait. No, it just copy one line. I'm sorry. This one just copy one line. It's wrong. Okay. Let's delete it. Oh, sorry. It actually had more. I'm sorry. So I'm going to delete everything. This is not good. Okay. This is not good. Let me copy it from a better source. Okay. Let's copy from Python's data structure course. Right there, Union 2. Nice one. Intermediate programming, let's see here. Python data structure, right here. List. Sorry, it's not. Let me do this in different way. Okay, let's actually copy this whole thing. Let's don't put it into the C language. Okay, let's actually copy it. And then here, let me try to use C++. Okay, right here, let me create a new one. Let's call it, this one, call it postfix. Okay, just call it postfix.txt. I'm going to put it right here, okay? Let's change the name. Call it the py. Okay. I think this actually is wrong, still wrong. Let's delete it. This is not a good idea. It's not a good idea. It's actually wasting time. So this one is in their data structure before. Let's see where they are. Let me try to find it, okay? Sorry. Not in here. How about Python data structure? Lecture, let's see. Data section is UNAM4. UNAM4 has a step. So let me try to go to the Python UNAM4 program. Not here. Python 2018 Python. Here, UNAM4, this one. Let's took a step. Reverse of the step. Now this one. Okay. This one, UNAM4. So maybe this one going into this one, basic. So here it has a step. I'm sorry, not this one. UNAM4. Recursion. Okay, I cannot find it. But anyway, let's actually type it, okay? Let's just type it. I think type it is even safer, maybe safer. Okay. Because it's not too much, let's do typing, okay? So let's put it in here so far. Okay, so this one, let's do define, do this to postfix. That here, let's do this expression. Okay. Okay, and then they have operand state. Postfix needs to be equals mg token equals whatever. Okay, this one is not important because we already do tokenization, so we don't need that. So for token, let's finish it. So this one, okay, let's actually finish it. Then for token, okay, let's do this. Okay, copying probably still not a good idea. Let's directly write it in C double plus. That's probably a better idea. Okay, let's don't do this one. Okay, let's actually just delete it. So let's directly write it into the, so here let's do conversion to postfix. Okay, so this function is called it. So it's an infix tokens to postfix tokens. So we are going to output tokens. So that should be a vector of the strings. Let's see what output that tokenizer using vector of strings. So that let's also return vector of the strings. Okay, let's also return the vector of strings. So this one is called it infix to postfix. Okay. And then you need to enter some sort of vector of string. Let's call it tokens. So you get tokens and then you want to convert it to output vector of strings. Okay, and this one, let's use the alias. Okay. And then the priority level, we already got it, so that's not a problem. Stack, we need to have a stack of string. So here you do have a stack of string. Let's call operand stack. Okay. Let's call operand stack. And then we do have another one that's called postfix list. So this one is a vector. Let's see, it actually should be a vector of string. So let's call it post. Okay, let's call it postfix. And then we do have a token list. Okay, token list is the token. So let's put it now. So here for every string token tokens. Okay, we do something. This one, put it now. Create a for loop. And then at the end, there is another one that's called while loop. So while the not the operand state empty. Okay, so while not operand state empty. The state using empty function that's actually decline. Okay. So this one, no parentheses, is a step. Okay. Do something. So that do something, we'll do it later. And then at the end, you need to do join of the postfix function So you have the postfix, but you need to do join function, okay? So return. So right here, you will return a string. So here, that's actually change the opposite, not a token, that's actually to string, okay? So let's see. Okay, so we got the tokens and we want to create it to string. So let's do string SS equals empty string. Okay, and we do got the tokens in the vector of the postfix. Okay, so let's do this. Let's do for integer I equals 0, I less than the postfix assigns I increase. Okay. And then if I equals 0, then SS plus equals postfix postfix of I, okay. And then else SS plus equals, that's a space plus the postfix of I. So each token will be separated by a space. Okay, so we will keep the whole thing spaced, but it actually is in postfix script. Okay, so this part, okay. This conversion at the end, conversion to that is okay. So now we have one for loop and one while loop to finish. So while loop is easier. So it actually is. We will do while loop is easier. So let's do this. Let's do this one is postfix that pushback of upper step up. Postfix is something wrong. Okay, let's see. This one, what's wrong? It actually, you have postfix. Postfix is a vector of string, and then why pushback is wrong? Pushback argument type, okay? Argument type is wrong. So your upstack is vector step of string. Pop function no, I think pop is okay. Something wrong. Let's check, okay? So let's check. C double plus step functions. So C double plus, yeah, is called pop. It's a push and pop, okay? And then we also need to know about vector, okay? Vector is not pushback. C vector. C double plus vector of string. Yeah, I think it's pushback. Something wrong. Why is push is wrong? Argument are void. Argument type are void. Okay, we'll check it later. Okay, so basically this one is the function right here. You actually pop out everything to the end of the postfix. Okay. Now we go into the for loop. So the for loop has if something, else if something, and else if something, then else. Okay, this is the structure of the program. We copy program, we do this first. Okay, so basically there is left parenthesis and right parenthesis. So this two is easier. It is token equals left parenthesis. Okay, and this one is token equals right parenthesis. Okay. Okay, if you are busy, you can just dismiss. Okay, and I'm continuing to do it because I think this one will take longer. Okay, is that okay? Hello, you hear me?
Yeah.
If you have something to do, you just go. Okay. I think this one I'm just converting it into C double plus, but it will show you the whole thing can be converted into C double plus. Okay. This one I'm trying to move it. Okay, I'm sorry. Okay. Good. Okay. So this one is left parenthesis, right parenthesis, and nothing else. Okay, so this one. Okay, and this one is actually you need to check if the token is number or it is so this one you need to do regular expression match function. Okay, so the regular expression not in here. So I'm going to copy the regular expression in. So here the is number check. Okay, so we need to copy this. This is 3 in regular expression and the regular expression match. Okay, copy this. So under match is right here. You can put it right here. Okay. So this one you need to add one more input function that's for regular expression. Okay, so we finish that. And this regular expression match is okay. So that's calling. Copy. And then go down. So if it is regular expression, this one of the token and numbers, okay, or regular expression match of the token and what's that? IDS, ID. So it's a token or ID. Token or ID will do one thing. Let's go back. So the token or ID, we will push it into the postfix list directory. Okay, so basically you do have postfix push back the topics. The topic. Okay, you just do this thing. And then let's look at right parenthesis. So left parenthesis. So left parenthesis it will push into the operand step. So this one is operand step, push the token into there. Okay, and the right parenthesis. Right parenthesis, you actually copy it out and then do while loop. Okay, this one a little bit complicated, so let me copy it. Okay, not too many lines, so copy is fine. Okay, not too many lines, so copy is fine. Let's put it over here. Okay, it's okay. We will change line. Okay, so basically, so let's declare something called string. Okay, and string top token is top out from operand step. Okay. So then next one is actually file the top. Let's change it to lowercase. Okay. Put it in more like C double plus format. This one more suitable constructor to convert. Okay, I'm going to check what's wrong. Okay, the stack. So what top tokens now equals the left parenthesis. We do something. Okay, then postfix that push back of the top token. Okay, and later top token equal operand step the pop. Okay, let's delete this part. We don't need them anymore. Okay, let's go back to here. Look at it. It actually is top token that pop out, and then check it is left parenthesis, and then she push it. Okay, so that's okay. Now here we do see some problem. Operand step pop. Take a string pop, remove the first element, which typical step it was synced by 1. The time compressed operation depend on the operator. Inline function pop function. If no data criteria is so here I'm sorry, I don't know why this one had the error. Okay. So let me check. Simple plus stack pop. Let's see when you use pop, anything that we need to take care of or not. So there's a push function and pop function. Let me check the return value. So C double plus step pop return value for pop function. Oh, the top function did not return any value. Okay, so that's okay. The top function did not, so that's usually use the top function and then operand step that top here. Okay, so it actually do read the top, and then we do pop later. Okay, so this one the same thing. Here we do the top function, and then we do operand step that pop later. Okay, so top token, no operand match the operands. Why no operand match the it's okay now. So this one the same thing. Probably we actually need to do string top token equal open step but top. Okay, and then open step part right here. Okay, it's a separate function. So right here, let's remove this one, and then let's put top token right here. Okay, so that part finished. So we actually finish translation of from Python to C++ with the token checking, and then that parenthesis and right parenthesis. Now is the operands. This one right here, that's actually, these are all possible, not operand, these are operators. Okay, these are all possible operators. So working on the operators, we have another three lines of the code. Okay, let's copy it. Copy this three lines of the code. Okay. Okay, so this one is why do this. Okay. So now I'm going to translate it into. So the last one, this one push is okay. Just this one step push the token, that's okay. And this one we change into the while loop of C style. So while not operand step that empty, and there's a parenthesis. This is where certain level of something greater than equal to where certain level of something. So here this one's token. Okay. And then the other one is operand step. So operand step that call. That's the peak function. So I think this is okay. This part can be deleted. Okay. And then this one's postfix. That push back. Okay, you do need to do the pop and then add. So let's do curly brace now. It's actually not enough. Okay. So right here, you do need to have the string of token.
I'm sorry, Dr. Chow. I have to go now.
Yeah,
Thank
yeah,
you.
no
Bye.
problem, no problem. Okay, sorry for it.
Thank
Sorry
you.
for being long. Okay, anyway, this one done. And this one now needed as deleted. So here you have precedence level of operand that pop. For some reason, they don't take it. Okay, so let's see. Precedence. Oh, it is a character. It is not a string. So right here, let's put that at 0. Okay, that at 0. Since it's only a operator, it's only an operator. So at the 0, it's actually okay. It's only one character. Okay, so we are done right here. We actually finished the conversion of infix to postfix. So let's call it, okay? Let's call it. So at the very end, we do one thing. Okay, we basically put the result converted to tokens. Wait. Oh yeah, that's actually tokens. So this token got fit into the infix to create a string. Let's call it string. Okay. Postfix expression for this. Okay, and then let's do cout postfix expression. And let's get from postfix expression and then enter. Okay, and then this tokens output will be coming now, because tokens right now we don't need to print out each tokens. That's for debugging purpose. So that coming now. So now that's okay. We are ready to read in an expression, convert it to full, parenthesize, tokenize, and then put it back to postfix. And then later, next time, we'll do evaluation next time. Okay, we'll still have one more thing to do to evaluate a postfix. So this one, poetry, double flash, infix, postfix, cpd dash o infix to postfix. Wait, something wrong? Something wrong. Where is it wrong? They are missing parentheses 121. Only one error. 121 is wrong. 121 missing semicolon. Okay, sorry. One moment, okay. Let me take the phone call from my. Okay, sorry. So that is done. Let's actually do it one more time, okay? So double plus infix to postfix is all indexed to postfix. I forget this. That's CPP. Sorry. Okay. After the long run, let's do infix to postfix 1 plus 2 times 3. Wait, we got the fully parenthesized, but we do not see the postfix impression. We do not see it. Let's do one more time. Okay, let's actually turn on the tokens, see if the tokens are correct. Okay. So let's do it one more time. So up to the tokens, okay, but we do not see it converting into the postfix. Let's actually go to, so we do, let's see if we go to this here, let's go to right there. So here, let's do token by token. So let's actually print out each token. Okay, so CL token and go. Okay, see if that token got in every time. And then see which token creates trouble. Okay, save. The token got 1 plus 2 times 3. So tokens is okay. Tokens got in every time is okay. But now let's look at the return value. So let's see. It is the return value that creates trouble. Return value is a string. Oh, so I'm sorry, we did not declare string postfix. No. We need to know about the string. So at the very end, we do create a SS. So return SS. So right here, we do got every tokens. So that's the postfix. The postfix is a vector of the string. So here we do go down to here. So let's do CLSS every time. Okay. CLSS every time. So here, let me comment out these tokens since it's okay. The token come in, no problem. But at the end, when we pop out the tokens, let's see the pop out the token to SS. So SS not seen. Okay. So here, let's see one more time. Okay. So basically, this one, I see it's okay. The tokens created okay, but the CL of the SS is failed. Something wrong there. Something wrong there. So let's see. Something wrong in the SS. So let's see out the SS size first. Oh, I see. This actually postfix pushback. So here, let's see. Let's do. See the size of the postfix. Okay, I'm sorry. Let's actually do this. And let's have one more line. So we will know it. Okay, so let's do one more enter here. This one is to debugging before. I think the string somehow is not created correctly. Okay, so let's check it. Okay, so we do have this one. Okay, and then do this. At the end, even postfix the size is not seen. Okay, so I see something wrong with the postfix vector or the string. The postfix is wrong. So let's do this. Okay, let's do. Every time, let's actually do CL. Postfix the size. Let's actually do this. Okay. Every time, let's do postfix the size. Okay. So the token got created, but when we print the postfix, it actually never got right. When we print the token, that's okay. So postfix has some problem. Okay. Postfix is a vector of the string, and every time we have a match, we push it. We push it. We just here postfix just get the pushback every time. So the pushback somehow doesn't work. Pushback doesn't work somehow. Okay, let's do this. Let's do CL whenever it actually. Whenever we actually do pushback. I mean the token that push out. every time there's a pushback. So somehow the postfix have problem. We only show up here and here and here. Okay. So let's see every single thing that here we have top token. This one we push top token. Wait, so here this one checking for this, that maybe is wrong. Let's see. Actually, this one is only the left one. Not that right. Okay, so basically this one, the while loop never go in because the Visual Studio Code generate a right-hand side for me automatically. That's actually very, very wrong. That's a tiny problem. Okay, it's actually the editor just insert the extra parentheses for me. That's actually wrong. I don't like this kind of editing. So let's do in this to postfix 1 plus 2 times 3. It's still wrong. Let me see, let me save it. It is still wrong. Let me actually go for every token. One more time. Okay, see each token, do they push it to the pushback or not? Say, let's do it one more time. Okay. There are a lot of parentheses. That's wrong, something wrong. Let's do one more time. So in this tool, postfix. So the token got created. When we try to print something, the token not created anymore. Even not the first token. So let me see. Let me actually do here. Let me do here. Let's do CL. And here, C will go into this function. Okay. And go. In this to postfix 1 plus 2 times 3. So it never go into this function. It doesn't go into the increase to postfix function. Let's see. We do here. We got the tokens. We print out every tokens. Okay, we print out every tokens, and then we go infix to postfix with tokens. So we pass the tokens into here. Let me take out these areas. Let me take out these areas. More time, let me save. It doesn't go into the function. Okay, we are already quite long, quite late. Hi, Sherry, you can be dismissed, okay? I'll keep debugging, okay? Sorry.
Mhm.
It's just some minor issue. It doesn't go into this function, okay? I'll check it.
Okay.
Good
Thank
night.
you. Good night.
Okay. So basically this one worked. The only thing problem that I do see is like I think that's my compilation error. Here it already generated a postscript. I just do one thing. I just do not compile to input that into outfix postfix. I compile it to AA, and AA executable work. So there's no problem. There's only problem is I do have during the compilation I do use the uh, wrong execution, and when I compile to it, it actually do not compile new file. Okay, so that's wrong. Let's do it one more time. Let's try a more difficult expression this time. So up to the fully parenthesized is okay. Somehow this one got stuck. And the fully parenthesized they have an internal problem. I think that's my own problem. Okay, so that's actually related to the release of the program. There are still some bug when they got released. There's some still some bug. So let's go back to the fully parenthesized. This one. So here you do push this. That actually is you do push this, but when you push a single operand, that I think is fine. And in this one, you still need to separate them. So that's actually doing this here, okay? That's actually also add the extra space to it. Okay, one more time. That's just because the fully parentheses, they do not create extra space. Nothing wrong. So here that's I think this one also. Okay, let's see. So there's an operand push. There's an operand push here. There's operand push here. Okay. Let's see this one, this version. Let's try one more time. Okay. Let's create a new terminal. But now, so let's actually create a new file. I think because the program is still running for some reason. Let's create 3A, okay, instead of 2A. To solve it, I think you need to put the whole environment to kill the AA's linkage, okay. So this one's okay. Let's do one more. Okay, I think this one worked already, okay? So there are two things that are changed. One is because there's a tech program in the environment. So I did not actually terminate them. So whenever I continue to compile the infix to Postgres, it failed. So just create a new program that will work. Secondly, there's another extra problem that happened on the fully parenthesized. Here, I just update the parentheses with the space at some location, but there are two more locations I forget to create it. Okay, that's it for today. Thank you. Bye bye.